Guys, today we're looking at some circumference problems working with pi, so working out exact answers, not rounded answers. Let's get started with some simple examples. Remember that the circumference formula is 2 times pi times the radius. So given that the radius is 18 centimeters, work out the circumference of the circle in terms of pi. That means that we're not actually going to use the value of pi on the calculator. We're just going to write our answer as something times pi. So that's just going to be c equals 2 times pi times the radius is 18, so I put 18 in the place of the radius, and 2 times 18 is 36, so the circumference is just 36 pi centimeters. It's actually easier working in terms of pi because you don't have to work out your answer to some number of significant figures. Here's another example. Given a circle with a circumference of 8 pi centimeters, work out the radius of the circle. Okay, so this time they gave us the circumference. So we'll start with the circumference formula as we've got above. Circumference is equal to 2 pi r. But knowing that the circumference is 8 pi, let's put that in instead of the c. So 8 pi is equal to 2 pi r. Now we just need to rearrange that to find out what r is. And I know it looks confusing with those pi's in there, but you'll see that working with the exact value of pi is going to make this easier because it's going to cancel out really nicely. To get the r on its own, we need to take the 2 pi to the other side. On this side, it's dividing, or multiplying, excuse me. On the other side, it'll be dividing. So 8 pi divided by 2 pi, we can simplify this fraction. We can divide both the top and the bottom by pi. Or even more than just pi, we can divide both the top and the bottom by 2 pi. 8 pi divided by 2 pi is just going to leave us with 4. The pi cancels out. So the radius is just going to be 4 centimeters. Example 3. Now this time you're given a circle with a radius of 14 over pi millimeters. Work out the circumference. Okay, now this looks really confusing because it's got a pi in it and it's got a fraction in it. But we're going to use the formula as usual and you'll see it works out really nicely. The circumference is 2 times pi times the radius. So we'll say that the circumference is 2 times pi times, we're told the radius is 14 over pi, so we'll put that in the place of the radius. And when you multiply by a fraction, you only need to multiply by the top part of the fraction. Think of this as 2 pi divided by 1 times 14 divided by pi. I multiply the 2 pi by the 14, and the 1, which I'm imagining underneath this whole number, multiplies by the pi. So that's going to give us on the top of the fraction, 2 times 14 is 28, so 28 pi. And on the bottom of the fraction, it stays just as pi. Now this fraction can definitely be simplified. I can divide both top and bottom by pi, or simply do 28 pi divided by pi, and the pi will cancel out. The circumference is just 28 millimeters. Simple, right? Let's try some practice of your own. So here I'm giving you some radiuses, or radii, diameters, and circumferences, and I'm asking you to find the missing value. So if the radius of a circle is 18, you should be able to work out its diameter. Remember, the diameter is just 2 radiuses. And you should be able to work out the circumference using the formula either 2 pi r or pi times diameter. Hit pause if you need a minute to copy this table and fill in your answers. Right, I hope you've hit pause because here come your answers. If the radius is 18, the diameter is twice that, so that's 36. And the circumference is just pi times diameter, so 36 pi. Next line's a little bit more difficult. If the circumference is pi, then the radius is going to be a half, because remember we do 2 times a half times pi to get the circumference. That's going to be 1 pi. And the diameter is just twice the radius, that's 1. Next row, if the diameter is 3 over pi, the radius is going to be half of that. So either 3 over 2 pi, just putting a 2 on the bottom of that fraction would be the same as dividing by 2. Or some of you might have written this as, it's a bit of an improper fraction, putting a decimal in a fraction, but half of 3 is 1.5, so 1.5 pi. And the circumference is the diameter multiplied by pi, so that's just going to be 3. See how nice that that's simplified? Right, next one, we've got a circumference of 12.5 pi. Remember that to find the circumference, it's 2 pi r, so the 12.5 must be 2 radiuses. So one radius must be 6.25, and the diameter must be 12.5. Next row, we've got a radius of 5.3 over pi, which means the diameter should be twice as much. So that's 10.6 over pi. But remember, we don't really like decimals in our fractions, So you could write an equivalent fraction timesing both top and bottom by 5. That's 53 over 5 pi. And as a circumference, remember we just do the diameter times pi. That's just going to be 10.6. Last row, probably the most difficult one. If the diameter is 7.5 pi, the radius is half of that. That's 3.75 pi. And their circumference, either 2 times the radius times pi, or just the diameter times pi, it's going to be 7.5 pi squared, because I did 7.5 pi times another pi, so the pi is getting squared. Let's move on to something a little bit more challenging now. These are some circumference problems, and I want you to work out the exact answer in terms of pi. I'll just go through and explain them for you first. You can hit pause and work them out, and you'll see the answers at the end. So this is a 400-meter track, where the inner racetrack consists of 2 100-meter straight lengths, so that's this 100 meters, and on the other side here, that's 100 meters, and 2 100-meter semicircular arcs, so the arc around here is 100 meters, and the arc around the other side is 100 meters, making a total distance around this racetrack of 400 meters. Now work out the perpendicular distance between the two straight sides. I've labeled that D for you here. And notice I used the letter D for distance, but you should also notice that D is also the diameter. If you were to consider this is half of a circle. That's the other half of a circle. And from the question, you should know what the circumference of the full circle would be. So given the circumference of a circle, work out the diameter. Hit pause if you need to copy that question. You will need the diagram to help you. And let's move on to the next question. Now this question's about a bicycle wheel with a diameter of 62 centimeters. So here I've got a diagram for you of a bicycle. You maybe just want to draw up the circle for the wheel. The diameter is the full length through the center across to the other side, that's 62 centimeters. And we need to work out the circumference of the wheel. So pretty straightforward, working in terms of pi, you've got the diameter, work out the circumference. Part B of this question is a little bit more challenging, a little bit more demanding. Now the wheel rolls over a patch of wet paint, and you can see I've marked a little bit of red paint on the wheel here. So now it makes a mark on the road every time it turns. Every time that wheel rotates, it's going to touch the ground with the paint and it's going to make a mark. The paint continues to leave marks on the road as the bicycle continues to travel a distance of 2 kilometers. Watch out for the units of measure here. Centimeters, kilometers. Okay, part B. How many marks of paint does the wheel leave on the road? Keep in mind that the wheel is rotating, rotating, rotating some number of times. We need to know how many times, because every time it rotates, it touches the ground with this bit of paint. So how many rotations are there in 2 kilometers? Think about what one rotation is. How many of those fit in a 2 kilometer distance? Right? Example 3. A paint roller has a width of 18 centimeters and a diameter of 55 millimeters. Again, pay attention to the units of measure here because they're not the same. Either convert this to millimeters so that they're the same, or convert this to centimeters so that they're the same. Now, see the diagram I've got here for you so you can understand how this works? A paint roller is a cylindrical shape. It's round, and it's got a width of 18 centimeters and a diameter that's around the circle, cutting through the diameter, is 55 millimeters. You should be able to work out the area that this roller paints every rotation, because it's going to be a width of 18 centimeters and a length depending on the circumference of that circle of the roller. Right? It's going to make this rectangular shape. Width 18, length, you need to work that out. Work out the area the roller is able to paint in a single rotation, so that one rectangular shape that I just described. Part B. A wall is 8 meters long by 2.5 meters tall. At least how many rotations of the roller are needed to paint the wall? So to cover that wall, you'll have to work out what the area of that wall is, and be careful here because this is in meters, and remember up here we had centimeters and millimeters. So you're going to want to convert these units of measure before you start. work out the area of the wall, and see how many of these areas it takes, so how many rotations it takes to cover that area. Remember working in exact values in terms of pi. Hit pause if you need to copy that. Otherwise, let's move on to the answers. So the answers, exact answers in terms of pi, I hope you haven't rounded your answers to 3 significant figures. So this first one, the diameter of the circle, or the distance between the 2 straight parts of the track, is 200 over pi meters. So if you had worked that out to 3 significant figures, do 200 divided by pi, you'll get a long, non-terminating decimal answer. You can round it to 3 significant figures, but this is the answer that I wanted, the exact answer in terms of pi. Right, our bicycle with the bit of paint on the bottom. Part A, the circumference of the wheel should have been really simple working in terms of pi. The diameter was 62 centimeters, so the circumference is the diameter times pi, 62 pi. The harder bit was how many marks it leaves on the road. It's going to leave 100,000 over 31 pi marks. Now that's left as a fraction to keep it exact, but I started by looking at the full distance that wheel is going to travel, and I divided that by the circumference of each turn. So how many turns will fit into that full distance. But I had to simplify my fraction to keep it as simple as possible. Again, if you work this value out as a decimal value, check that this value multiplies out or calculates out to give your answer. Finally, painting the wall. The paintbrush or the roller is going to paint an area of 99 pi centimeters squared for each rotation. Or if you did that in millimeters, that's 9,900 pi millimeters squared. Or if you'd done that in meters, that would be 0.0099 pi meters squared. Now, if you'd done that in meters squared, that might help you to work out how many rolls or how many rotations it takes to paint the whole wall. But I would have rather changed the wall calculation to work out the area of the wall in centimeters. Here's the number of rotations it takes to paint the wall. See, I used my centimeters area for the area painted by the roller, and I divided the total area of the wall by the area that I can paint with one rotation of the roller. Okay, once again, I hope you worked in exact values, but if you didn't, calculate this out, 200,000 divided by 99 pi, and you should have your answer to 3 significant figures.